Well, good morning, everyone. Welcome to Designing for Q-SYS VisionSuite. We're going to cover a couple of different things today. The first thing that we're going to go through is we're going to talk about what is VisionSuite. There we go. We're going to go over some of the features of the cameras. We're going to go through ACPR, and then we'll go through Seervision, which is the AI-based camera tracking. So let's talk a little bit about what is VisionSuite in general. So a lot of you are probably used to us talking about ACPR. This is automatic camera preset recall. We have, over the last year or so, we have wrapped VisionSuite to become the Seervision product, which is our AI-based presenter tracking, with ACPR, which is our audio-based preset recall. And all of this comes together to be called VisionSuite. So the first thing that we want to talk about is the cameras. So what we're going to talk about are our three native Q-SYS cameras. The first of which is the NC110. This is a fixed lens EPTZ with 110-degree FOV. All three of the cameras are PoE. They are just network devices. So all you have to do is just put them on the network, and they can then be accessible by the system. So the NC110 is a fixed lens, wide angle. The other two are our PTZ models. So this is the 1280 and the 2060. The 1280 is 12x zoom with an 80-degree FOV, whereas the 2060 has 20x zoom, but just a 60-degree FOV. The 1280 is the default camera for most things. Most rooms don't need the 2060. The 2060 is really when we start to do larger rooms where the camera needs to be farther away. So those are the three cameras. These three cameras can be used with the ACPR plugin and Seervision, and they both feature a 4K image sensor, and where we deliver up to a 1080p stream. There is an HDMI output on the back of the PTZ cameras, and they will put out the full 4K off of that HDMI input. But as far as network stream goes, we just put out up to 1080p. So let's talk about the features in these. The first of which is auto framing. So this is a newer feature. This will, inside the camera, there is some processing that happens where we will attempt to detect people's faces and then crop out any of the dead space around the faces that we see. There are a couple of things that you can change as far as the settings go. The first of which is what we call dead banding. This has to do with how much area do we leave around the faces that are triggered. The other is, dead banding has to do with when you move back and forth. Padding is the frame padding is actually how much space do we leave around the people's heads. So when you get into the actual camera itself, and you open up the block, you'll notice that there will be an auto framing tab, so you can enable it and disable it. This can also be done from within the ACPR plugin that we'll look at here in a little bit. This is where you can change the frame padding, the transition speed. This has to do with when we see new faces or a face leaves, how quickly do we make the change to reframe the subjects. We can turn on and off the face count. This gives you a read-only field. And there is a way to turn on what we call outline faces. This puts a big green box around people's faces. This is visible to the far end, so this is something that you'll just want to use when you are testing or commissioning a room, but ultimately you're going to want that turned off. So let's look at the actual cameras. On the website for the cameras, there is a distance calculator, which will help you pick which camera to use in a specific situation. So you can go through and just put in the distance, and it will tell you, at that distance, the size of the subjects that you'll have, and it helped you narrow in on which camera to use depending on your room. So let's talk about automatic camera preset recall. So this is our audio-based tracking, if you will. What it does is it waits to get a signal from some sort of a microphone or audio signal, and then uses that to recall some presets in the room. This can absolutely be combined with auto framing. This runs with a plugin. So if you do want to use this, a scripting license is required, but we're going to go over sort of how to set it up, what we're looking at as far as equipment goes, and then just sort of some best practices for making it work really well. So the first thing we want to talk about is the difference between ACPR or audience-based switching versus an actual presenter tracking. So ACPR is just going to use fixed predetermined positions and then recall those based on getting some audio information from either some discrete mics and using just an audio meter to know when someone is talking in there. Or in the case of intelligent microphones, we can take the coordinate data and use that to know where someone is speaking in the room. Camera tracking is something that we also offer, and we'll look at it in a little bit in this webinar, but this really has to do with continuously adjusting where the camera is aimed, both positionally and from a zoom standpoint. So that requires some AI-driven backend so that we know who is a person to be tracked. We're constantly evaluating where they are relative to the camera. That's a different kettle of fish entirely. So we will let's lean into the ACPR side first, and then we'll look at the AI-based presenter tracking. So this is a little graphic that shows automatic camera preset recall. So there's a ceiling mic in the room that will give us coordinate data. When the gentleman in the blue starts talking, we know where they are based on the coordinate data from the microphone. We use that to tell one of the cameras where they are, and therefore which camera preset to recall. Whoops. So this is just a very quick, graphic. That's how that works. In this one, we are using primary and secondary cameras. We'll dig into that in a little bit as far as exactly what that means. So this is just an example of how we can, the Q-SYS Open idea works. All of this with ACPR is all based on a plugin that was initially created as a proof of concept test by one of our application engineers. So it just just a Lua script, and then it has evolved into, a plugin and a component that we use. However, it is all just based on Lua. So let's talk about what we need for ACPR from a system component standpoint. Obviously, we need a core. We're going to need some of our cameras, and then we're going to need some intelligent microphones or discrete microphones. There are a number of these that are supported natively inside the software. So when we go in, for those of you that have used this in the past, you're used to automatic camera preset recall being its own plugin and named in Asset Manager. We have changed that up a little bit. It is now in the VisionSuite plugin. So once you download the VisionSuite plugin, that will include the ACPR as well as the Seervision plugin. It's all packaged together now. And you'll notice that we've had some revision number changes. It was 2.3 when we first brought it out, and then we rolled into the second phase, which was all version 3, and some minor revisions from there. But what you'll notice now is that everything is starting at version 85. This was to allow us to align the version numbers with the firmware on the Seervision servers. We decided to just sort of, recalibrate all of our versioning, so that as you go through and are using all of VisionSuite, it's very easy to just know, okay, my Seervision server is at 85, so therefore my Seervision plugin and my ACPR plugin can all be, should all be at 85, just so I know that everything matches. So once you have that in there, there are a couple of system components that you'll need. The first of which is the ACPR. You'll need to have a MediaCast router in there. That's how we control which camera is getting sent to the far end. You'll wire all the cameras in there. Also, we can support the Sennheiser TCC2 and the TCCM, as well as the Shure MXA920 and the Audio-Technica AT&D 1061. Those are all have built-in functionality into the plugin. If you're trying to do this, also the NMT1, our microphone, that is also baked into the plugin. If you're trying to do it with maybe a dais style where everybody has their own mic in front of them, there is a discrete microphone mode where you can say, okay, if someone is talking into this particular microphone, I want you to aim this camera into this particular position. So that is also a way to make that work. So let's talk a little bit about the cameras and how we run them. We run what are called primary and secondary cameras. So we can have up to 16 primary cameras, which each primary camera can have a secondary camera assigned to it. So you could theoretically have 32 cameras running, 16 as primary, 16 as secondary. One of the most common things that comes up all the time is can a primary also be another camera's secondary? No, that's really not the way this is meant to work. Can a particular camera be a camera, more than one camera secondary? Also not the way this is designed to work. When it comes to primary and secondary cameras, the idea behind this is that every primary will have its own secondary, and they will be dedicated, because what we're doing is we are creating a logical pair inside of the plugin that refers to these cameras as a single unit. So if you start trying to mix and match with primaries and secondaries, you can get some really unwanted behavior. So this is a very common setup. This is our experience center in Austin. You can see where we have the two cameras right next to each other. One of them is the primary, one of them is the secondary. What this really helps with is if you've got a single pair of cameras and you have 4 or 5 zones that are dedicated to be covered by those, by that one camera position. If you have somebody talking in zone 1 and then immediately someone starts talking in zone 2, what we don't want to have happen is for the far end to see the camera swing around and then try to refocus and rezoom and all of that. That is not a very pleasant far end experience. So we try to minimize that. And the way we do that is with the primary and secondary cameras. So we will have the primary, if the primary is looking at zone 1 because zone 1 was talking and then someone starts talking in zone 2, instead of watching that camera move over, we will just have the secondary camera point to zone 2. And then once that camera is in its final position and lets the plugin know that it is in its final position, then we make the switch to the far end. So it's very much like having a broadcast quality experience for the far end, in that we move the camera, then we make the switch. Likewise, if we're in our same scenario and someone starts talking in zone 3, well, the secondary camera is being used to point to zone 2. The primary camera is still looking at zone 1, but now someone's talking in zone 3. So now the primary camera will move over because the secondary is the one that's currently in use. The primary will now move over and pick up zone 3. And once it reports back that it's in its spot, then we'll make the switch. So we're removing all that visual pan and tilt from the system. So here's our example again. The gentleman in blue is already talking, so the primary camera has picked him up. The other fella in green now is going to talk, so the secondary camera will move over. And once the secondary camera has gotten into position, then we will make the switch to the far end. All right, and then we've got the other camera. So if multiple people begin talking, or if the far end is talking, which is our example here, we have a default shot set up that will shoot the entire room. And this is all configurable inside the plugin. You can turn on and off the default home position setting. You can decide how long it takes to go to that. All of this is able to be modified to your whimsy. But that is also something that we do support, so that when the far end is talking for an extended period of time, you're not just locked on the last meeting participant that was talking. You can now go to a wide shot of the room so they can see everyone as they present. Now, if this gentleman gets up and walks to the front of the room, again, because we have coordinate data and we know what we're doing, we can set the front up as a zone, which will then trigger that rear camera to go ahead and pick him up. And now the far end can see him up at the front with the display behind him. And this just makes for a very nice, very clean far end experience. So here are the microphones that we were discussing earlier. So we've got the Sennheiser Team Connects, both the TCC2 and the TCC-M. We've got the Audio-Technica AT&D 1061 and the Shure MXA 920, as well as our NMT1. We can also handle the discrete microphones. This is what it looks like in the plugin when you first go to set it up, where you go through and pick which microphone you're going to be using. And then it can also support multiple microphones as well. Steve has a question about an MXA 310. I am no Shure expert, but if I recall correctly, is the 310 the one that doesn't give us coordinate data? Or maybe it does. I don't know. If you have questions about other microphones, you are welcome to email them to me. The other thing is these are the ones that are baked in right now, because these are the microphones where we can open up a network connection and get coordinate data back from them. The microphones that are just lobe based, there is a way that you can make those work in the system under the discrete mic setting. You just need to make sure that it's not a microphone where the lobes shift around, because we're going to essentially assume that that microphone has fixed lobes and then treat it like discrete microphones. So these are the intelligent microphones. You can have up to 10 of them in each plugin, meaning that if you've got a room, especially divide combine rooms, where you are going to need to be able to at some point have 4 or 5 microphones in different areas, you can absolutely do that. You can dedicate zones per microphone, and then by coordinate within those individual microphones. This is what it looks like when you are, my thing is not happy today. There we go. So once you are in the plugin, for every microphone you have, you will see that microphone listed up in the top. You'll give it an IP address so that we can connect to it and get the coordinate data back from it. You will also connect an audio signal from it. This is a unique audio path just for the plugin to know that we have signal coming to it. So we know which microphone has an active talker in it. It's one of the ways we decide which microphone and which zone to trigger. So the other option on the Audio Technica is you can actually create the camera zones in the microphone and then have it report that back as far as just which zone has been triggered. This is the same way that the NMT1 works. It looks a little different in that we're not really worried as much about the horizontal and vertical as we are which camera zone is getting triggered. So when you put the AT&D into camera zone mode, you no longer define the zones based on the coordinate data. You've actually already done that in the microphone. Then we're just looking for feedback from the microphone telling us which camera zone has been triggered, and then we will recall the presets. The NMT1, it comes as sort of 4 quadrants of the microphone. That's how it presents itself inside of Q-SYS Designer. So we just run those 4 in based on which one has the highest signal. We then recall a preset based on that. Discrete microphone mode. This is what I was talking about earlier when I was talking about like either some sort of a dais, or if you've got a big boardroom where everybody has a microphone right in front of them. We can handle up to 90 discrete microphones in a single instance of ACPR. And I say it that way because there is no reason that you cannot run more than one instance of ACPR in any particular designer file. We do it all the time, especially with either multi-purpose spaces where one day it's going to be a boardroom and one day it's going to be classroom style. You may take that same room and put 2 instances of ACPR in there, and then there's a tracking bypass pin that you can wire into a selector, and then you can just give them the option to pick their modes, and then it'll just essentially turn one plugin off while the other one is on, and then vice versa. So I say that to say that if you had some crazy room where you had more than 90 discrete microphones, you could do it with multiple ACPR plugins. When you do that, every microphone becomes its own zone, which then has camera presets tied to it. So let's talk about ceiling microphones and ceiling microphone placement. This is an issue that we run into fairly often, where people will just load a room up with microphones because they think it's needed to make everything work perfectly. This is a really common room layout that we see, and the tendency is to put the microphones like is shown right here. The problem with that idea is that people tend to turn and face the front, so they don't always face the microphone, especially these people up in the front. When people are talking and they have their body turned and the microphone then ends up being at a 90-degree angle from their head, it gets hard to hear them. So we generally recommend that you evaluate the space in the context of which way are people going to be talking. It will make it sound better to the far end, but it'll certainly also make your ACPR work a lot better. The other thing to remember is that a lot of these microphones will include some sort of an exclusion zone. This is to make sure that we are not getting a lot of reflection, especially if it's a room that has windows going down one side and maybe it doesn't have shades that go down. You will find that the people that are sort of facing the window, the microphone will bounce back and forth between their actual voice and then hearing the reflection come off the window. That can really create issues. So if you go through and have the ability to set up exclusion zones, it will make it work a lot better. But what about this area in the middle where we're between the two microphones? Do we have something that can combat that? Yes. The newer versions of the ACPR plugin include what are called crossover zones. You can think of this as a giant OR gate saying if mic 1 shows this coordinate or mic 2 shows this coordinate, then we will recall this zone. Every microphone has 4 crossover zones at the bottom of its tab, but you can mix and match. So if you have a zone, say you, in just a weird situation, say you have 2 microphones and you want 8 crossover zones. I don't know why you would, but you could. You could go onto the mic 1 tab and set up 4 zones with the crossover mic being mic 2. You could then go to the microphone 2 tab, set up 4 more zones with the crossover microphone being mic 1. So you can mix and match them coming from different directions and get accomplished what you need to accomplish. One of the other features this has is what's called crosstalk. This has to do when multiple people are detected at the same time. So if 3 or 4 people are all talking at the same time, instead of the plugin trying to bounce around and figure out what's going on, it will trigger what's called crosstalk detection. You can set the speed at which that happens. You can also set that up to be a custom crosstalk level, as shown here on the expert controls. But what it'll do, if it detects crosstalk, it'll just go back to that default wide shot until we go back to only having one person talk at a time. So the expert controls, there are things that you can set on your own. We typically recommend that people understand what these do. If you haven't taken the in-person ACPR and Seervision training, I highly recommend it. We go into a lot of detail on these. But essentially what you're looking at here, silence home position. If no one is talking in the room, it will go back to that wide shot. Same thing with how long does somebody need to be talking on the far end until we recall that wide shot. We have our expert controls for our crosstalk. We also have mic audio detection and far end audio detection. So these are, relative to how long or these are a way to really dial in the difference between no noise in the room and noise in the room, or someone talking in the room. And then we have some others for zone hysteresis and home position masking. Home position masking is something that's new. If you have only primary cameras but don't have secondary cameras, as long as you have one camera that you can dedicate to that home position shot, if say I've got a camera, I'm in a zone, the person next to me is in a different zone, they start talking, I've been talking, now they're talking. Instead of seeing the camera move, because we don't have a secondary camera, we can tell it to switch to that home position while the camera moves. But that is a fixed time. So you need to tell it how long you want it to stay on that home position. And that's what's done with home position mask time. Also, if you are updating or migrating some other systems starting in version 3, there is a load settings option. This becomes very helpful if you need to, essentially, if you wanted to duplicate your settings from an older version of ACPR, you can just put in the component name and hit copy, and it will just literally make a copy of it in the newer version of the plugin. So let's look at some very quick design examples. This is a huddle space. We've got an NMT1 in here. We could very easily drop in the NC110, and we could use that to just to shoot the whole room. We could then add some of the network sound bars in here. We could even add a secondary microphone. So in this one, we've only got 5 seats. This one, we get a little bit bigger. These spaces don't necessarily need ACPR. these really could just benefit from the auto framing that's built into the cameras. So once we start getting into bigger spaces, this is a medium conference room using some NMT1s. As we increase our capacity, we may want to increase our feature set as well. We can have the two cameras sitting up above the displays. We can run those as primary, secondary. But this is really when we start to get into ACPR. So in this example, we would be using the quadrant data off the NMT1 to decide where to point the camera, or we could go ahead and switch over to an intelligent microphone in the room and then use our coordinate data as well. So as we start getting into bigger rooms, then we need to start talking about maybe adding more cameras. So in this example, we could absolutely have a pair of cameras either above or below the two displays. It's becoming slightly more acceptable and more used that if you're doing dual displays, to split them a little bit and actually put the cameras in the middle. This gives you a good opportunity for having the cameras at eye height and yet still being able to have that central look where you're shooting down the middle of the table, which makes it easier to cover both the left and right sides out of just that pair of cameras. And then last thing that we want to look at are flex spaces or combinable rooms. So in this example, we've got A and B, but we've also got an air wall in between. So in this case, we would actually run 3 instances of the ACPR plugin. We would run one for each room when the rooms are separated. So we would have a room A and a room B. But then once we combine the rooms, we would have a third instance of the plugin to redefine this system for our combined space. So again, this is what I was talking about earlier. There is a tracking bypass button, which can also be brought out as a control pin. That will let you decide which ACPR plugins are active at any given time. So let's talk a little bit about higher ed. This is obviously a very popular use case where we want to be able to have a presenter up in the front, but also engage the audience in the back. For any of you that had the good fortune to come through either our ISE or our Infocom booth, you saw us use this during the tour. In this situation, we've got 2 intelligent ceiling microphones. These are used for giving us coordinate data and to be able to pick up the audience. So if someone is talking up in the front, then we'll switch to that rear camera and move the camera back and forth. If someone is talking at the podium, we'll go ahead and swing over and catch that. But if someone in the audience starts talking, we want to be able to use the front cameras to accomplish that. So this is a very basic example of just one camera front and back. This is probably not how you would want to do this. You would probably want to have multiple sets of cameras, but the idea here being that we're using intelligent microphones in tandem with some local microphones, either a wireless or a desktop microphone up at that podium. And then because we've got the intelligent microphones, we can use their coordinate data to come back. So let's talk about incorporating ACPR into your UI. We do this quite often where we place the controls onto a user interface by using some layering and whatnot. We can go through, and if the we can turn the auto framing on and off for starters. We can also enable and disable the preset recall. So in this instance, if the preset recall is disabled, now we can pick which camera we're looking at manually. We can manually drive the cameras. But once we enable the auto preset recall, we go ahead and drop all those controls off and just give the preview. And then we can even go so far as to enable the auto framing. Once we do that, then this system really is autonomous. So now you can go back and forth. So we can do auto framing without the preset recall. So if you want it to be in manual mode, but also include the auto framing, you can absolutely do that as well. One of the questions that we get fairly often is, how can I manually control them? There are Q-SYS plugins available for Visca control, as well as for the Scarhoy PTZ controllers. So if you are in a scenario where you've got a larger room, and when you go to this manual mode, you don't want it to be driven off of a touch panel, you've got somebody that wants an actual tactile joystick, these are two options that will help you achieve that. So let's talk about some of our best practices, things that we want to make sure we cover in here. In general, everything starts with gain structure and AEC. You want to be very careful with the acoustic properties of the room. Rooms that have a lot of reverb in them will definitely give you issues. There's a saying that mechanical issues in a room can only be solved by mechanical means. We can't get rid of we can't compensate for somebody being too far from a microphone or too close, or massive reflections in the room. We can combat some of it, but we can't completely fix all of it. Set the expectations when you're talking to the customer. We really do want to avoid having cameras that are 14 feet in the air that look like they're just shooting at people's foreheads all the time. And then one of the biggest things is, when you're configuring your presets, we usually talk about putting 2 to 4 people in every shot. This is much more natural. It lets the people on the far end see the person that's talking, as well as the people that are on either side of them. So you get their sort of visual cues from them as well. But then you can combine that with auto framing. So if you do widen your shot out a little bit, but there's only one person, you can then crop into them as well. So let's talk about, working with camera control systems. So when you're doing this, we want to make sure that people are talking toward the microphone. We want to make sure that, the talkers are being as loud as they can. We want to acoustically treat the room. And then if we've got an issue, or if we've got a room where there's only, one person in there, let's make sure that we have them as close to the mic as possible. All right, so in review, let's look at, automatic camera preset recall, what it is, what is required. So this is a plugin. We can use secondary cameras as well as primary cameras. We can use intelligent microphones. We can have multiple instances of the design, and we do need a scripting license to do it. So I'm going to script through this because this was part of a different presentation, clearly, and we're going to jump right into Seervision. So Seervision is a company that we acquired a year or so ago. They are an industry leader in AI and machine learning as it comes to active presenter tracking. This is the other half of what we have now rebranded to call VisionSuite. So what this does is, this is like having a camera operator sitting in a room that is controlling the position of the camera, as well as the zoom of the camera. So this is computer vision based. We go through and we take 14 points and make a skeletal frame. And this is how we decide what is a person and should they be tracked and how to track them. So these shots are preset by whoever is using the room. And you can do everything from full body shots to, you know, just like shoulder up shots. All of that can be, you know, can be custom configured. So how do we do this? Well, we're using the exact same parts and pieces that we used for ACPR. We're just adding in this Seervision server to do the actual AI learning and to send control commands to the cameras. So this is another example of what it looks like inside. This is computer vision. This is our software and algorithm that's running inside. And we use this to evaluate where a person is relative to the tracking camera. And then we send commands to that tracking camera to move the camera so that that person stays where we have told them to be. You know, generally this is centered, but you can absolutely, you know, skew them one side or the other if you care to. This is a little bit of what the interface looks like. We work in what are called trigger zones. So trigger zones are what start an action. We also have what are called tracking zones, meaning that if someone is in the tracking zone, we will go ahead and track them. We can also have exclusion zones. So if they walk in front of a display that has people on it, we won't try to start tracking the people in the display. So this is a little bit of the GUI. First thing we have are the streams. So this are the video feeds that we're getting in. We do this with just RTSP streams from our cameras. So that's what we're using, that we are constantly evaluating. We have the trigger zones. This is what starts an action. Exclusion zones, meaning that we won't begin tracking something that shows up in an exclusion zone. And then we have tracking zones. These are all custom configurable. And this is all gone through much more in depth when you start doing the VisionSuite commissioning certifications. The last thing that we have involved are what we call containers, or you can think of these as presets. There are two types. Shots are used for tracking. This will tell you like what kind of shot you want, where are they in the frame, things like that. Position are used for static camera shots. This is if you've got a whiteboard or a podium or something like that. If someone walks to a podium, you don't necessarily want the tracking to stay engaged, so you'll just go to a position shot. This is basically the same thing that we do in ACPR, where the camera goes to that position and stays until we tell it otherwise. So we've gone over the fact that we need the Seervision server. The Seervision server comes in two flavors. They are a 1-channel and a 2-channel. They are the SVS1 and the SVS4. So this has to do with how many video streams we need to evaluate at a time. This has nothing to do with the actual number of cameras in the room, because you may have cameras that are just for ACPR. Those do not all require a Seervision server channel. It is just the ones where we need to be able to evaluate what that camera is seeing, so that we can, you know, either do tracking or static shots from the Seervision side of things. So just as with ACPR, we're going to have a core, we're going to have NC series cameras in, and then we will have our Seervision server. We can run cameras in two different concepts. The first of which is a tracking camera. This is the camera that actually moves. We can also run, we can also evaluate what is called a conductor camera. So if you think about having a director, if you're doing a live broadcast, you would have one person that is constantly looking at the entire front and then telling the camera operator, you know, if somebody else walks into that space, hey, you need to zoom out so that we can see both of these people, because the camera operator, they are just tunnel vision locked into what that camera sees. So they're just focused on the one person they're focused on. This is the exact same concept as how tracking cameras differ from conductor cameras. So we can use conductor cameras in our system to be able to constantly keep a view of the presenter tracking area, so that if we have multiple people walk in, we can know to fall back to a wide shot so that we make sure we see everybody. All right, which camera to use? The FOV and the distance are what are going to help you decide that. If you are looking at just doing full body shots, then obviously you don't need as much zoom as you do if you are trying to do close-up shots. So just sort of do some evaluation and go over that scope with your client before you go through, just to make sure that you have the cameras that you need. So the last thing we're going to do is we're going to go through the supported Seervision use cases. We have predefined some supported cases, some use cases right now. We will obviously be expanding these as we expand the functionality of the Seervision integration with Q-SYS. But the first is, just sort of a single presenter. This is pretty basic. We're looking for someone to walk into that green area. When they do, they become tracked. When they leave that area, we go fall back and we wait for the camera to see someone else come into the zone. This just requires one tracking camera and a single channel for Seervision, because we're just looking at the one camera. So you would end up with, obviously we've got a core, we've got a single camera in the back, and we have a one channel. We've got an SVS1, which is a one channel Seervision server. When we start to get into what we call single presenter and static, so when they are in the zone on the right, this trigger zone called presenter tracking, they will be zoomed in on, and we will track them as they move through that area. However, as they move into that leftmost area where we've got the podium and the whiteboard, we will just go to a static shot. So in this example, we've got the static camera, but since we don't need to evaluate what that static camera is seeing, we're doing all of this based on the presenter tracking camera. While we have two cameras in the room, we're really only using one channel of a Seervision server, because we're only looking at what that one camera sees. So we can then, of course, combine these with our ACPR. So then we can have our presenter up in the front, but we can also engage our audience in the back. That begins to look a little bit like this. So we still have our presenter tracking area. We still have our whiteboard area up at the front. We've got our static camera for that, but we are just still using the one channel of the Seervision server, because we still only have one presenter tracking camera. Any of our ACPR cameras, our static view cameras, none of that gets factored in when we're deciding how many channels of Seervision we need. Okay, so when we get into multi-presenter, this is when we need to have the two channels, and we need to have a conductor camera so that we are constantly keeping an eye on the entire presentation area. So it looks a little bit like this. We've got this big presenter area up in the front, and we now have our two cameras, one for tracking and one as a conductor camera. So therefore, we have a two-channel Seervision server in there, and that way we can direct the cameras where we want them to be. So let's talk a little bit about how we quote this. I'm not going to go super deep into this, but basically we're looking at, is it single presenter? Is it multi-presenter? Are you going to have static cameras? Are you going to integrate ACPR? All of this gets done through our professional services division. So if you are interested in learning more about how to quote this and how to work it, you can reach out to your area managers, and they can get you set up and walk you through this process. So we use our professional services to help deploy this. And that is just to make sure that as this product is sort of in its infancy, we want to make sure that, you know, we get you the best experience. So until we get to the point where we have, you know, tons of trained dealers all over the world, we'll help you with our in-house folks to get your Seervision system up and running. So the last thing is, let's just, you know, cover some of our best practices for Seervision. You know, make sure that the area is big enough. Is there a designated presentation area? Do we have a clear shot of them? We want to make sure that our camera positions are where we want them. Make sure that you have exclusion zones set up so we don't get a lot of false triggers. You know, make sure you're using static cameras if you've got areas like podiums or whiteboards or anything like that. And then one of the really nice parts about Seervision is that it is just a network appliance. It is a big 2U server. You probably don't want this in a credenza in a room. So, you know, you're going to want to locate that in an IT closet that's close or something like that. So those are just things to consider as we go through doing this. Any questions that I can answer on this? I realize this is a ton of information, and we will send out a copy of this slide deck so that y'all can go through it, all 100 and something slides there are. So you'll get a copy of that. You'll get a copy of this recording within, you know, a week or so after this. I send this to marketing. They package it all up and send it out to everybody that registered. So you can go back and watch this at your leisure if you feel like you missed something. I'll stop sharing real quick. But if nobody has any questions, then I will let you. Yeah, okay. So Matt has a question on here. The conductor camera needs its own channel, plus the tracking camera needs a channel as well. Yes, each individual server can only do a maximum of 2 channels, but there's nothing that says that you can't run multiple servers in a space. So we've done a couple of them where we'll have multiple presenter cameras, maybe multiple conductor cameras, and we just run multiple servers. Each instant, when we talk about a 2-channel server, functionally, the instances of the software that are running on these servers are not aware of each other. So the Q-SYS plugin and the core is what's handling all of the communication between the instances of the server. So there's functionally no difference between having a 2-channel server and 2 1-channel servers. Likewise, if you need 3 channels or 4 channels, there's no functional difference between having 2 2-channel servers and 4 1-channel servers. So it's pretty plug and play as far as it being modular, that you can just add these in as you find that you need them. Al's got a question. What procedure should a tech follow when updating firmware on the core? I mean, it's pretty much the exact same. Really, when we start to talk about, you know, procedurally as it pertains to VisionSuite, that really comes into if we're going to update the firmware on the actual Seervision server. We do that during deployment, that we go through and update the software on the actual servers themselves. And then, it kind of depends on, we have license terms as far as how long you can get support as far as getting new firmware versions loaded on. But it is a manual process. It doesn't just happen on its own, because we want to make sure that everybody is aware that this is going to happen, because you're also going to need to update some of the plugins and things like that. So the firmware on the cores really doesn't affect Seervision, only in as much as you need to be on I think 9.9 or higher is when we started introducing auto framing. There are some requirements on that, but other than that, there's nothing special that you need to know about that. All right, any other questions? If so, feel free to throw them in the chat. Otherwise, we'll get out of here. I hope everybody has a great rest of the week. As always, I can be found. My name is down there. I am Steve McCary. You can always find any of us here at Q-SYS, first name dot last name at qsc.com. So if there's anything I can do as far as follow up or any questions that you may have, feel free to reach out to me. Otherwise, have a great week, and we will see you on the next one. Bye, everybody.